science estimates that only 10% of the universe's total matter would be visible to us. The rest would be dark matter. This matter has totally unknown properties, as it would not have left traces that could be tracked. One of the variables that would have been eliminated by dark matter would be time. As without time there could be no movement, this matter must be stationary. A theoretical explanation for the problem would be to say that, because it is extremely dense, dark matter would have contracted time to levels where it could not be measured. Under these conditions of timelessness, intelligent life could not have arisen on Earth. For this, it would be necessary for there to be an inversion in the flow of time, which would allow its dilation and the emergence of relative movement. In this way, thanks to a temporal inversion, space-time would have emerged in the form of a negative bubble of information within dark matter itself. At the center of this bubble would be the observer. After this inversion of the arrow of time, which science suggests took place shortly after the Big Bang, the observable universe seems to maintain some signs that would be characteristic only of dark matter. For example, to abandon its condition of being static, dark matter would have, initially, stretched space. Thus, all matter in the universe would have been concentrated in a small point in space until the inversion of the arrow of time. Information about this negative curvature movement of space by the action of dark matter would have been recorded in cosmic radiation, and, as soon as the arrow of time reversed, they would have been projected into our past. The redshift would be the direct result of this stretching of space before the Big Bang. It would have appeared when all the matter was concentrated in a single point in space. Interestingly, the increased curvature of space would predispose to the emergence of time as a result of this negative stretching movement. As the resulting force would point to the resting position of this concentrated matter or in the opposite direction to the curvature of space, this time could not be directly measured. For astronomers, the Big Bang would have been accompanied by a temporal inversion related to the gravitational collapse of a very massive body forming a black hole. As would happen in the formation of a black hole, the stretching of space should contract time until the exact moment when its arrow reverses. Thus, time would have had its beginning in the Big Bang. Thanks to its continuous post-Big Bang dilation, direct measurement of time finally became possible. So, if the curvature of space has been increasing within dark matter, it would be logical to expect that after the singularity and the time inversion, space would have gradually lost its curvature. This would explain the gradual and continuous separation between galaxies after the Big Bang, since, before it, they would have been together. Space would leave its expansionary phase and enter the opposite phase. the absence of measurable time before the Big Bang justifies the idea that all dark matter would be placing itself outside space-time. Another alternative interpretation would be to say that the contraction of time would have placed dark matter virtually in our future, which would be expressed in the delay to which light would have been submitted to travel a greater area in space. The delay in communicating its curvature suggests that space would have depended on a cosmic messenger in which the aforementioned change in its geometry was indelibly recorded. As the bearer of information, the event would be communicated by light outside its own time. The contraction of time in our future, then, would express itself in the fixed and limited velocity assumed by light just after the reversal of the arrow of time.